Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1, and today's chapter is Improper Integral. In this chapter we have today's topic is Improper Integral of first and second kind. What is the meaning of first? We will understand what is the meaning of improper integral. Then what is the first kind and second kind? So let's start with the first definition of improper integrals. The integration a to b f of x dx is called improper integral if one or both limit of integration are infinite. That means this a or b or both will be infinite, then we can say that this integral is improper integral. And the function, if the function f of x, that means this function f of x becomes infinite at the point, this point, or within this point a to b, in between a to b. Okay, so if function f of x becomes infinite at the point within or at the end point of the interval of integration. So in two cases we can say that given integral is improper, that either of this limit is infinite or both, or this function become infinite at end point or within this interval of integration. Okay, there are three kind of improper integration classified into three kinds. There are three kind of improper integral. Okay, so in this lecture we will take only first kind and second kind, and next lecture will be depend on third kind. Okay, so let's start with the first improper integral of first kind. That means type 1. We can say type 1 also. So if the integral this integral is called improper integral of first kind or type 1 if either lower limit, that means this, or upper limit, that means this b, or both are infinite. Okay, so either of this a or b or both will be infinite, then this integral is of first kind, that means, or we can say of type 1. Okay, like this. For example, here you can see its lower limit is infinitive, so it is first kind. Upper limit is infinitive, so it is first kind, and here both limits are infinite, so this is also of first kind. Okay, so we have these three type of example in this first kind. How to solve this integration when limit is infinite? So for that we have this following method. Okay, number 1, if f of x is continuous on a to infinity, that means this kind of example, a to infinity, that means its upper limit is infinity, then integration is written as this form, in limit form. That means wherever this infinity is given, we will take the limit b tends to infinity and we will put this infinity b. So we will write down b instead of infinity. Then we will integrate first, we will put upper limit minus lower limit, then at the end of getting the integration, answer of this integration, we will put the value of limit. Okay, so this is the process, and no need to use every time b. You can use c, d, a here I have just already used, so I am using b. You can use c, d, e, f any later. Okay, so no need to use compulsory b. Now same way for this, if lower limit is infinity, so it is continuous on minus infinity to b, then this minus infinity is taken as a, so limit of a tends to minus infinity and this minus infinity becomes a, and b as it is, upper limit b as it is. So this is the how we can evaluate these two, if upper limit is infinitive, if lower limit is infinitive. Now if both the limit is infinitive, then this is continuous on minus infinity to infinity, then first we will find inside point. That means in between minus infinity to infinity, we will find one point A. A might be any point at which this function should not be infinite. Okay, so we will find a point A where this function is finite, and then we will take limit for this infinity, minus infinitive and this infinitive. So for this minus infinitive we have taken B, and for this infinitive we have taken C. So here B to A, and this become A to C. A is as it is. A will be as it is. There is no change in A. Okay, because we have taken point A which gives this function value finite. So we have to find this limit and this limit, and by adding this we will get the final answer of this. Now if all in this all 1, 2, 3, this improper integral in 1, 2, 3 are called convergent if this limit, or that means this answer of integration is finite, that means limit exists. So limit exists, that means this corresponding limit exists, that means if we will get the finite answer of this integral, then the given integral is convergent, and if we get infinite answer, that means does not exist, then the limit, this integral is divergent. Okay, so in this chapter also some questions are given like this, the convergence of the integral. Okay, at that time we have to keep this thing in your mind. If answer of integration is finite, then it is convergent, and answer of integration is infinite, then it is divergent. So simple. To understand this kind, that is first kind, let's have a look on the example. We have one first example. Evaluate integration 0 to infinity 1 upon x square plus 1 dx. So it is its upper limit is infinity. Okay, so it is of first kind. Okay, simple. So it is of the first kind. Now we will take limit for this infinity. So we have limit t tends to infinity. I am just taking here t. As I told you, can use A, B, C, D, any alphabet. So I am taking t for t tends to infinity. So this infinity becomes t, and the rest of the everything is as it is. Now first we will find the value of this integration, and we know the integration formula. So we have to use only basic integration of the standard. So we have 1 upon x square plus 1, and integration of 1 upon x square plus 1 is tan inverse x, upper limit minus lower limit. So tan inverse t minus tan inverse 0. Tan inverse 0 is 0. So this will be 0. And after this, we will put the limit of t tends to infinity. So tan inverse infinity, and we know the value of tan inverse infinity is pi by 2. So answer of this integral is pi by 2. If it is asked, is the convergence, that means it is asked given integral is convergent or divergent. So the answer is finite, so we can say that this integral is convergent. Okay, but here there is no need to write down that because it's asked only evaluate. Second example, determine whether this integral is convergent or divergent, and if it is convergent, then find the value. If it is divergent, then you know that, and if answer is infinitive, then it is divergent. Okay, so now we have to just check answer is infinitive or infinite or finite. So its upper limit is infinite, so it is first kind example. Okay, first kind, that is type 1 example. So we will take limit for the upper infinitive, upper limit infinitive, so t tends to infinitive, 1 to infinitive. Now integration of this 1 upon x square, as we know that integration of 1 upon x square, we have to take x square to the numerator, and that then we can apply formula of integration minus 2 plus 1 upon minus 2 plus 1. So x is to minus 1 upon minus 1, and which means minus 1 upon x. So integration of 1 upon x square is minus 1 upon x. So by after upper limit minus lower limit, we have this, And after getting the answer of integral, we will put the value of limit. That means t tends to infinity. So if you put here infinity, to 1 by infinity is 0. So we have answer 1, which is finite. So given integral is convergent. And the value of integral is 1, because we get answer, find answer is 1. Okay, so this is the process how we can find the value of integral and how we can check the conversion and divergence. So we have two more example. This is the example where lower limit is infinite, so we'll take limit for this. Okay, so this is first kind example, type 1. So we'll take limit for this minus infinity, so t tends to minus infinity, and here we will put t. Now we have to integrate this. For that, we have to use Bernoulli integration, as we have studied in chapter Fourier series. Okay, formula of integration normal u v. Okay, so by Bernoulli, you can use integration by parts, but Bernoulli will make it easy. So first u as it is, this u as it is, integration of v minus differentiation of u, that means differentiation of x is 1. Again, integration of this is e raised to minus 2x by 2, and this 2 is already there, so 2 to the 4. Now, just we will put upper limit minus lower limit. So, by putting 1, so this will be 1, this will be 1, and this will be 1. So, we have this upper limit minus lower limit. After simplifying this, upper limit minus lower limit. Now, after putting this, we will simplify this. So, we have same e square, you can take simple LCM. So we have e square by 4. After opening this bracket, minus plus. So we have this, and by putting t tends to minus infinity. And we know that e raised to minus infinity gives us 0. So if you put here minus infinity, so this both term will be 0. So we have final answer is square by 4, which is finite. And finite, so given integral is convergent, and the answer of integral is e square by 4. Simple. Okay. So this is the another example. Now we have third example in which both the limits are infinity. So we have to decide one point in between this minus infinitive to infinitive at which this function should not be infinite. So we will take 0, because at 0, 1 upon 1 plus 0 is 1. Okay, so we will split this limit minus infinity to infinity in two parts, minus infinity to 0 and 0 to infinity. Okay, so first kind of example, minus infinity to 0, 0 to infinity. Now we will take limit for this minus infinity and this infinity. Okay, so we have, and we will evaluate separately both. So first we will evaluate this limit. So 0 to infinity. Now taking limit for this infinitive, t tends to infinitive, and here t, and we know the formula tan inverse x, upper limit minus lower limit. Then by simplifying, this is 0. By putting infinitive, we have pi by 2. Same way, we will find the limit for this limit. If both the limits are finite, then original limit is finite, and that's why this given integral is convergent. Out of these two, either this or this is infinite, or both will be infinite, then original integral is infinite, so given integral is divergent. Okay, so to make this convergent, both integrals should be finite value. So we have one value is finite. Now we will find this minus infinity to 0. This first one, this one. Okay. So we will start minus infinity to 0. We will take t tends to minus infinity. So here t, and find the integration of 1 upon 1 plus x square. So tan inverse x, upper limit minus lower limit. So tan inverse 0 will be 0. So we have minus tan inverse t. If we put t tends to minus infinity, so tan inverse of minus infinity is minus pi by 2, and minus is there, so minus plus pi by 2. So we have both the answer are finite. So given both the integral is convergent, so original given integral minus infinity to infinity is also convergent. And we have value, original value is given by pi by 2 plus pi by 2 is pi. So this integral has final answer pi. Okay. So this is the process how we can solve the first kind. Now we have second kind, that means type 2. All the process will be same, just you have to identify it is of one kind or second kind. Other than that, there is no change in process of example. Okay. So now we have, if it is the finite integral and in which integrand becomes infinite, or we can say that unbounded or discontinuous at one or more point within or at the end point of the interval of integration. That means if this integration is given, then if this function f of x is infinite at a or at b, then we can say that, or within this point a to b, within this point, this f of x become infinite, then it is of second kind. That means now in second kind, the limit of this integration, is not in infinity form, but the function become infinitive at the end point, or maybe the point inside this limit. Okay. So we have this example. You can see, if I put infinitive here, 1 by infinitive and 1 by x become 1 by, if we put 0, 1 by 0, that means this becomes infinitive. So it is of second kind. Here limit of this integration is not in infinity, but this function become infinite. Infinite, that means we can say unbounded or discontinuous. Now here you can see, if I put 4 here, 4 minus 4, 0, and 1 upon 0, that means infinite. So this function become infinite at this point. Now we have one example, this 2 and minus 2, at both the limit value, this function is not infinite. But if I put 1 or minus 1, then this function become infinite. And 1 and minus 1 lies between, this 1 and minus 1 lies between minus 2 to 2. Okay. So as I told, at the end point or within the point, if the integrand, that means this function, become infinite, or we can say that unbounded or discontinuous, then it is of second kind. How we can evaluate this kind of integration? Same as previous. Okay, we have to take limit for the point at which this function is infinite. That means, number one, if f of x is infinite, that means unbounded, and x is equal to a. Okay, that means if we have a to b, f of x dx, then this function is infinite at a, then we will take limit for this a. So this a becomes c, because we have taken c tends to a. So c to b, f of x dx. If f of x infinite at x is equal to b, this, so we will take limit for this b. Okay, and as I told, we can take any a, b, c, d, but a and b are used, so we have taken here c. So now here c tends to b, because at b this function is infinite. So c tends to b, and we will use c instead of b. So a to c. Now if for the end point, or as we have said, a point in between a and b, this function is infinite, then at a and b this function is not infinite, but in between points c, this function is infinite, then we will take limit for this c. So we will take here d tends to c and we will put d, and here e tends to c and we will put e. A and b as it is. Okay, now we'll, as previous first kind, we'll find the limit of these two, and if both will be finite, then given integral is finite, so it is convergent. Either of these two is infinite, then given integral is infinite, and therefore given integral is divergent. Same way, if f of x is unbounded at both the end point, a and b both. So we have to find one point c at which this f of x is not unbounded, that means not infinite. Okay, because we have at a this is infinite, at b this is also infinite. So at c we have to find c at which function is not infinite. So at a, if we put a and if we put here b, okay, so this f of x and f of b finite, so we will take limit for a and b. So d tends to a, so d, and e tends to b, so this, and c as it is, because we have taken c at which this is not infinite. So these are the four, and these four we can say it is convergent, as we have discussed. If answer will be finite, that means limit exists, that is convergent. Limit does not exist, that is divergent, that means at infinite. So now let's have a look on the three different example. First example, if we put 3 here, 3 square is 9, 9 minus 9 is 0, and 1 upon 0 is infinite, so it is of second kind. So we have the second type, and we will take limit for this 3. So unbounded at 3, so we will take limit for 3, so t tends to 3 and t. Now formula of this, and we have the formula 1 upon under root a square minus x square, which is sine inverse x by a. Okay, so we will use that integration formula. Now upper limit minus lower limit, so we have this upper limit minus lower limit. Sine inverse 0 is 0. Now we have the sine inverse t by 3, so we will put t tends to 3. If we put 3 here, 3 cancel out, and sine inverse 1 is pi by 2, which is finite, so we can say that given integral is convergent if it is asked. Otherwise, this is our final answer, pi by 2. Okay, one more example. This here you can see that both the point, okay, there is not possibility. So solution here, it is of the second type of example, second kind of example. So now we'll write down this, and you can see if we put pi here, sec x, that means 1 upon cos x, and if we put pi, that means cos pi is minus 1, so it will be minus 1, not infinite. But if we put pi by 2, then we know that cos pi by 2 is 0 and 1 by 0 is infinite. So at pi by 2, this function is unbounded. Okay, that means discontinuous, or we can say infinite. So we will take limit for pi by 2. So we have taken limit for pi by 2, and integration of sec x is log sec plus 10, upper limit minus lower limit. So sec pi, as I told, sec pi will be minus 1, 10 pi is 0. So 1 plus minus 1 plus 0 minus 1, because of mod it is 1, and ln 1 is 0. If we put t, so this t. Now we will put t tends to pi by 2, so pi by 2, and we know that sec pi by 2 is infinite, is infinite, log undefined, so it is minus infinite answer. And as we know that if integral is infinite, then given integral is divergent. Simple. Okay, answer is infinite, then it is divergent. So simple. So one more example we have. Evaluate integration 0 to 3 1 upon x minus 1 dx if possible. Here you can see at 0 minus 1 it is minus 1, so 1 minus 1 finite. At 3 it is also finite, that means at end point given integrand is finite, but in between this point 0 to 3 there is 1.1, and at 1 minus 1 0, 1 upon 0 is infinite, so at 1 this integral becomes infinite. Okay, so this is of second type, and this is continuous at x is discontinuous at x equal to 1, and 1 lies between this interval. So we will split the given integration in two parts, 0 to 1 and 1 to 3, and we will take limit for this one, okay, by separately one by one. So first we will take 0 to 1, this limit, first part, and at that we will take 1. So t tends to 1 minus 1, the left hand limit, as you have learned in first standard. Other than that, there is no any change. So just integration of 1 upon x minus 1 is log x minus 1, upper limit minus lower limit. So we have this upper limit minus lower limit. After putting this, we have final answer is minus infinity. Now one of these is infinite, then no need to find second, because as we have discussed, either of this is infinite, then whole become infinite, and whole become infinite, then given integral is limit is does not exist and given integral is divergent. So simple. Okay, so first that we have find infinite, so it is divergent, so original integral is also divergent. So simple. And we have this DIYs of first kind and second kind. How we can decide first kind? If limit is in the form of infinitive, so it is first kind. In second kind, function become infinite, that means unbounded, that means discontinuous at the end point or in between any point. Okay, so these are the practice example. Keep practicing. After getting this practice more, you will understand next lecture of this topic, because this is small topic. Improper integral, we have only 2 lectures. This is the first lecture and next lecture is the last lecture. So after practicing this example, you will understand type 3, that means third kind, very easily. So keep practicing, keep learning, and we will see you soon with next lecture. Thank you very much.